So I'm going to show you that the fundamental theorem, I'm just going to give you an example of why the fundamental theorem of calculus part 1 is true. And I'll look at the problem, another problem that I did earlier, and you can see this video elsewhere if you're looking through my website. But this is what the fundamental theorem says, that if you have a function defined as an integral of something, and if there's a lower limit that's a scalar or a number, and an upper limit that's a function of x, you can just plug, and you're trying to find the derivative. So I'm trying to find the derivative of g. The derivative is like the inverse of the integral, and so they kind of cancel each other out. So all you have to do is plug 3x in for t, but then you have to multiply by, on the outside, you have to multiply by the derivative. And 2 doesn't even matter. The 2 on the bottom doesn't matter. So a lot of people think, well, how can the 2 not matter? Could it have been 10? Could it have been whatever? And the answer is yes, it could have been whatever, and I'm going to show you why that's the case. So let's pretend like we didn't do all of this stuff. And let's just try to find, so I'm going to leave my answer here, right? So I'll write the answer up here, 18x plus 9. That's my answer. Let's pretend like we didn't know the fundamental theorem of calculus. So what do we do? What's the integral of 2t plus 3?
I have a 6x long this time.
2t squared over 2 plus 3t, right? Do I have to write the plus c? I don't, because this is a definite integral, right? If there weren't bounds, then I would have to write it, right? But now what I'm going to do is I'm going to plug 3. It's going to be from 2 to 3x. So what do I do to find this? I plug this in first, and then I plug this in, and I subtract the one from the other, right? So this is going to be 2. So actually I could simplify this, right? So that's just t squared, right? Whoops. Follow? I'm canceling those 2's out. So what do I have? I have 3x squared plus 3 times 3x. I'm plugging that in, minus 2 squared, which is 4, plus 3 times 2, which is 6. I'm just plugging those in. So this equals 9x squared plus 9x minus 10. Okay, but remember that's g of x, right? What did I want to find? I wanted to find g prime of x. So now I'm going to take this and take the derivative of that. There's my 18x plus 9. So did the 10 matter? Where did these numbers come from? They came from the 2. So would it have mattered what you put in there? No, because when you plug those in, it becomes a constant, and the derivative of a constant is 0. So that's why it doesn't matter, and you can see now. So that's the long version of it. You could have done it the long way, but you don't need to do that because of the fundamental theorem of calculus part 1.